Polynomial models bookwork, exercise 4Z. Use your GDC to help sketch the graphs of these functions. Give the range for each function. So I'm going to do these two. I'm going to do number 1 and number 5. So I'll put number 1 here. These you're not expected to just graph them by plotting points. This you're going to use your calculator just like you've used your calculator for exponential functions and other functions. So first we're just going to put the function in here. You guys are experts at this now. You're going to put negative 0.5 x plus 1 plus 3 to the x. I'm going to graph it. Let's do zoom fit or zoom standard 6, option 6. Okay, and so here is the function. It looks kind of like this. You're just sketching it. Oops. Looks like it crosses maybe at y equals 2. But this is just a sketch. It doesn't need to be perfect. Then it says give the range for each function. So how do we find the range? Well, the range looks like it goes to infinity, right? Now what's the minimum value? It's about there. Well, since we have it in our calculator, we can use second calc minimum to find that point, right? So to find the range, you're going to use the minimum function, you're going to use the maximum function, one of the two, right? In this case, it would be the minimum. Let's go to the right bound. So we just mark a triangle on the left side of the minimum. We mark a triangle on the right side of the minimum. And then we say guess. Yes, that's our guess. Enter. And it calculates that our minimum is negative 0.717. So I'm going to put negative 0.717. And the y is 1.81. Okay, so what is the range? The range would be between, let's see, 1.81, because that's the y, right? The y value, so 1.81. And the upper limit is infinity. So you could also write that as just like y is greater than or equal to 1.81. That would be the range. Okay, now let's go to number 5. Okay, so let's put that in the calculator. We'll clear out this one. We'll put in 0.5 to the x and minus x to the negative 1. Graph. Okay, and number 5 goes down here. Oh, that's an interesting one. It looks kind of like that. Like a smashed parabola, and then this looks kind of like a hyperbola. Okay. Let's see. Let's find the range of this. Well, if we're going to find the range of this, it's a very different range than usual, right? Because like you can see that the function goes from here down and from here up, but between these 2 points, it doesn't exist. So we need to find 2 critical points. We need to find this point, which looks like it's about 0. And then we need to find this point, which looks like it's maybe about 2. So we can do that using second calc min and second calc max. So we're going to do second calc min first, and then this smashed parabola, we're going to find that first, okay? So we say, okay, what's the left bound? And we'll put it about here on the left side of the minimum point. And then we go to the right side of the minimum point, we hit enter again. And then our guess, we just hit enter. And it tells us that the minimum point is negative 0.884. Okay, so this point here is negative, negative 0.884, comma, 2.98. And then what about this point? Maybe we could see that using the table. So let's use the table, and then remember that if we go pretty far, we're going to see where this approaches. So it looks like it's getting close to 0, doesn't it? Now it's at negative 0.04, now it's at negative 0.03, now it's going to be at negative 0.02. And if you continue with this, you are going to see that it is approaching 0, but it's an asymptote, so it's never going to get there. Okay, so this point, it is approaching 0. Okay, now how would we write that as far as the range goes? Well, this part of the range we would say y is less than infinity and it's greater than or equal to 2.98. And then this part we would say y is less than 0. Would we say y is less than or equal to 0? No, because it's an asymptote here and it never actually touches 0. So if we want to write the whole thing, we would write y is less than 0 or y is greater than or equal to 2.98. Would we say y is less than 0 and y is greater than or equal to 2.98? No, we wouldn't, because it can't be both at the same time, so we need to say or. Okay, so that is our asymptote, or our range for number 5. Okay, now we're going to do last problem on this page, which is 4AB number 1. The water consumption in Thirsty High School is represented in this graph. We're going to open this graph up a little bit so we can see better. Write down the two variables represented by this graph. Well, the two variables represented are simply time, hours, and water consumption, liters. Okay. During what period of time is Thirsty High School open? Well, if this is water consumption, they don't actually tell you when the school is open, but you can kind of see that when the school is closed, probably there's no water consumption. So maybe starting here to about 20. So I would say from about, let's see, the middle, each one of these horizontal blocks is worth 2. So I would say it's like 5, 6. I would say it's 7. It opens at 7 o'clock. And it goes until 8 o'clock at night. Okay, so I would say that they're open from 7 a.m. to 8 o'clock. Okay, just based on the graph here. And then during what intervals of time is consumption increasing? Well, I guess that would be when these kind of go uphill like that. So those are the two intervals right there. So I would say that increasing happens between 7 o'clock and that would be like 12 o'clock, right? And then it would also happen between 1400 hours and about 1700 hours. Okay, so from about 1400 to 1700. Okay, and it's kind of hard to tell on this graph because it's so small. On the test, it won't be so small. Okay, and so when is it decreasing? Well, it's decreasing pretty much in the opposite time intervals. So like between 12 and 1400 hours, for example. And then between 1700 hours and when the school closes, 2000 hours. That's when it's decreasing. Find the time at which the consumption is at a maximum. Well, that would be this point here, right? So that would be about noon, right? So max would be 12 o'clock. And then find the time at which the consumption is at a minimum. Well, I mean, that would be when it's 0, right? So the minimum would be at 2000 hours until 7 in the morning. Okay, and it's at 0. Consumption equals 0 at that time. And that's it for page 1.